are starting with lesson 1.1, analyzing categorical data. Do you guys say data or data?
Data.
Which one's right?
Data.
Both. Very good. All right, cool. So we live in a world full of data, you guys. Every day we're going to find all kinds of data, whether it's a poll that was taken or a test score or anything like that. We might be looking at sports data. We're going to understand data using statistics, all right? So a solid understanding of statistics is going to help you figure out if people are telling you the truth and also what the data even means, all right? So first of all, what is statistics? Statistics is the science and art of collecting, analyzing, and drawing conclusions from data. Statistics is the science and art of collecting, analyzing, and drawing conclusions from data.
You gotta wait on this dude.
I don't wait long. All right, we are going to learn this year how to collect. We're going to learn how to analyze. We're going to learn how to draw conclusions from data. And in fact, you guys, do you guys remember Joy? What was Joy's superpower? She could smell Parkinson's. They utilized in that study the statistical problem-solving process, which includes these 4 things. You don't have to know all the little details. Basically, the overview will work. The statistical problem-solving process is you want to ask questions. When you guys are presented with some kind of data, you're going to want to ask some questions. Clarify what the problem might be and ask if it's valid. Do you agree with it? Do you think it's made up? You're going to want to ask some questions. Then you're going to collect your own data. You're going to want to design and carry out an appropriate plan to collect the data. We will learn this year how to design a good statistical study in order to get good data. We're going to definitely want to analyze that data. We're going to use graphical models, numerical methods to analyze that data. We will learn how to do that. That's actually what this first unit is about, is how to use graphical models to analyze data. Then we are going to interpret those results. Most important thing a statistician is going to do is to interpret the data that was given to them. So we're definitely going to do that. Here's one very important note. You always want to make sure that you answer the research question. A lot of times we get into the data, there's lots of stuff that we get interested in and we go off on a tangent. We always want to make sure that we go back and answer the original question that was posed. So can Joy smell Parkinson's? Maybe, maybe not. We want to make sure at the end, after we look at all of the different things about Parkinson's and about all of the things that are happening when she says she's smelling it, then we still want to make sure we can answer at the end, can she really smell Parkinson's or not? Okay. So, yeah, I know. Cool? I cannot smell Parkinson's or any other disease for that matter. I know. I barely can smell my food these days. Let's talk about roller coasters. Do you guys like roller coasters? Yeah. Okay. Here's some data on some roller coasters that have been built recently. And we're going to look at this data and we're going to identify some parts of this table here. The first thing we're going to talk about is the individual. An individual in statistics is a person, animal, or thing that is described in a set of data. The individual is a person, animal, or thing that is described in a set of data. Basically, you guys, for an individual, you want to answer the question, who or what is the data about? Who or what is the data about? Who or what? That's what you're trying to ask yourself. Who or what is this data about? Once you answer that question, then you'll know who the individuals are that the data is about. So, in this particular example, The roller coasters are the individuals, and their names are actually listed in the data table. Sometimes, however, that is not there. That column would not be there, and it would just tell me individual information, or it would tell me information about each individual, and the rows would be those individuals, which would be each roller coaster. The next thing is a variable. You guys have all heard about variables. I mean, if you've taken any math class, you know that a variable is a value that can change. It is any attribute that can take different values for different individuals. Those are our variables. In this particular example, the type of roller coaster is a variable. Depending on which roller coaster it is, depends on what kind or what type of roller coaster it is. The height is a variable. It can change depending on which roller coaster we're looking at. The design, the speed, the duration, those are all different variables that can have different values for each of those individual roller coasters. So all of those are variables across the top. Cool? Cool. There are two kinds of variables, categorical and quantitative. What do you guys think the difference is between categorical and quantitative variables?
Quantity or category?
Quantity versus category. You're pretty much exactly right there, Luke. So, the categorical variables are going to be the variables that take values that are labels, and they place each individual in a particular group called a category. Pretty straightforward, right? So, categorical variables is when we label an individual with a category. We put them into a specific category. Categorical variable takes values that are labels, which place each individual into a particular group called a category. These are usually easily identifiable because they are words, right? The type of roller coaster is a categorical variable because it is a word. We're going to either call it a steel or a wooden coaster. The design is categorical. We're going to either call it a sit down, an inverted, or a wing coaster. Apparently that's where you fly, like, I don't know, I guess, who knows. So categorical variables, those are the variables that puts individuals into categories. Quantitative, we are going to assign a quantity for these, right? So the quantitative variables are going to take number values that are quantities. Now, they can either be counts or measurements. So it could be that I'm just counting how many of something there is, or it could be that I am measuring something. These are the three different quantitative variables for this example. We have height, speed, and duration. I can measure height. I can measure speed. I can measure duration. Quantitative can either be how many there are, or it's some sort of a measurement that I take. Do you guys have any questions about individual, variable, quantitative, or categorical? Do you feel like this is the easiest class you're ever going to take in your life?
Yes.
So far, right? Now you're going to practice. So if you guys will flip the page, you will see an example. This example is from the American Statistical Association. They have a website called Census at Schools. They just collect various random survey questions. We used the site's random sampler, and we chose 40 U.S. high school students who completed the survey in a recent year. The table on the next slide displays data for the first 10 students that were chosen of the 40. On the very rightmost column, here's the question that was asked. Do you mostly want to be rich, happy, famous, or healthy? And they had to answer which one they would choose. What do you guys think? Would you most want to be rich, happy, famous, or healthy?
If you're rich, you're all of them. Yeah, if you're rich.
If you're rich, you're all of them?
Yeah, you can be.
You can buy your...
You could buy your happiness? You can buy your health?
No, just your health, and like you'll be famous if you have a lot of
It would
money.
help to be happy if you were rich.
You can also
You don't have to buy
If people who are rich are happy, then tell me why so many lottery winners commit suicide.
Well, that's like they couldn't adjust to the new life. That's why.
Everyone around them wants money and won't shut up about it.
Ah, good point, good point. Here is your task.
Maybe they ran out of money.
Maybe they did.
No, it's
Could have been. Here's your task, you guys. You are going to identify in this chart who are the individuals, what are the variables, and then you're going to classify each of the variables as either categorical or quantitative. All right? So I'm going to give you just about 2 or 3 minutes to take care of those 4 things: individuals, variables, and then which ones are categorical, which ones are quantitative. All right, so looking at this data, what would you say the individuals are in this data?
Tested students.
The individuals here are the 40 selected students. So, like I told you guys with the roller coaster problem, sometimes the individuals are listed, sometimes they're not necessarily listed. It's just that each of the individuals are in a row. And so the individuals here are each of the rows, all right? It's the students. So the individuals are the students, and they are indicated by each of these rows. All right, a lot of people think that it's the state just because that was the first column. Not necessarily. It's who or what is this data about? This data is about the selected students. Okay? All right, cool. What are the variables that you guys came up with?
The state.
Everything.
Yeah, everything.
Basically, if you go across the top there, those are all of your variables, all right? It's each of those columns that are across the top. So state, grade level, sex, age, blah, 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 blah. Cool? All right, here we go. Categorical or quantitative? State. Categorical. Grade level.
Quantitative.
Ooh, we'll come back to that one. Sex. Categorical. Age. Quantitative. Birth month. Categorical. Height. Quantitative. Arm span. Quantitative. And preferred status. All right, cool. The categorical ones are super easy to pick out. It's the ones that have words. Okay, so state, sex, birth month, and preferred status. The ones that are numbers seem like they would be quantitative, but what about grade level?
Yeah, just like replace it freshman, sophomore, junior, senior.
Did y'all hear that right there? Couldn't I have just as easily have written senior, freshman, senior, 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 junior, senior, freshman, sophomore, freshman?
Yeah, but they didn't.
I could have. I didn't. But what this shows you guys is that not all numbers are automatically quantitative. This is a category. Grade level is a category here. All right? I'm not counting anything. I'm labeling you as a 12th grader or a 9th grader or a 10th grader. I'm labeling you with a number. Just like your student ID. That is a label. It happens to be a number, but it's just a label. So it's categorical. Okay? And then obviously the quantitative ones we already talked about. Do you guys have questions? So let's talk about zip code for a second. Is zip code categorical or quantitative? Why?
Because that's like where you live.
All right, cool. So I want you guys to write this down. Yes, zip code is categorical. That's absolutely correct. Zip code is for sure categorical. But I want you guys to make sure you write this down somewhere. Not every variable that takes a number value is quantitative. If the variable shows a word, then yeah, it's categorical. That's pretty easy. But not every number is quantitative. Think to yourself, is this a count or a measure, or is it just a label? Your cell phone number, it's just a label for your phone. It's like a number label for your phone. My room number, that's just a label for my room. It's not necessarily something that I would ever average. I would never average a zip code. I would never average a grade level. I could average an age, but I wouldn't really, I'm not going to say, the average grade level in my class is 11.25. I would never say that. I would say most of the kids in my class are juniors or seniors. So, does that make sense? Perfect. All right, cool. Moving right along then. Distribution. The distribution of a variable is going to tell us what values the variable takes and how often it takes these values. Basically, it's how many of each item. It's how many of each variable. It tells us what values the variable takes, so that's like what the categories are, and how often, so how frequent does each of those things occur. There's lots of ways to display a distribution, and we're going to talk about several of them here in just a second. So a distribution of a variable tells us what values the variable takes and how often it takes these values. So the first way that we're going to display a distribution is something called a frequency table. What do you guys think a frequency table is?
Like how often?
It's a table of how frequent something shows up. That's absolutely exactly what it is. So, yes. Here is a frequency table. It's going to show the number of individuals having each data value. It's going to show the frequency or the number of individuals that have each of the data values. That's a frequency table. Table of the frequencies. So here is the data on the preferred status from those 40 students in that sample from before. And we're going to turn this is just the raw data. This is what each of the 40 students said, and it's not in any kind of order. We're going to turn that into a frequency table. Should be super easy. All we have to do is figure out how many of them said famous, how many of them said happy, how many said healthy, how many said rich. So it looks like you have some counting to do. Dun, 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 dun. I would verify with my friends what they get as well so that everybody can get the same numbers.
Shouldn't it just equal 40?
It should equal 40. That would be a very good way to check to make sure that you got the right numbers. All right, how many said famous? 7. How many said happy? 21. How many said healthy? And how many said rich? All right, now, as you guys have already said, this should equal 40 because it said there's 40 in here. And so if I do a quick little addition here, 7 and 21 is 28, plus 4 is 32, plus 8 is in fact 40. So we got all of our numbers. Do you guys have any questions about a frequency table? That's easy. Now we're going to turn this into a relative frequency table. What does relative frequency sound like to you? How often does it happen relative or compared to everything else? So it's basically how often does it happen compared to the total. So in order to figure that out, what we're going to do is we're going to turn these numbers into percentages or proportions. A relative frequency table is going to show the proportion. Now, when you guys see proportion, I want you to think decimal. The proportion is a decimal of something. Or the percent. A relative frequency table is going to tell us the decimal or the percent of individuals that have each data value. And it is going to be out of the total. So, famous. We had 7 out of the 40. If you want to pull out your phone calculator, that's totally cool. Or if you have your regular calculator, you can pull that out. Because I'm just telling you, I'll be honest, I don't really know what 7 out of 40 is. I know it's less than 25%.
But
I don't really know what it is, so. So tell me what is 7 out of 40 in decimal form? 0.175. All right, now, here is your first test to whether or not you should stay in AP statistics. What is 0.175 as a percent? 17.5%. Sounds like everybody gets to stay. 17.5% is correct. All right, Happy. We had 21 out of 40. What is 21 out of 40 as a decimal, as a proportion?
Something over 50.
It is over 50%. Very good. 0.525. And what is that as a percent? 52.5%. Perfect. Then we had 4 out of 40 for our healthy. What is that as a decimal? 0.1. And what is that as a percent?
10, but I corrected this one.
Wow. 10%. All right. And then Rich was 8 out of 40, which is 0.2, which is 20%. You trying to get kicked out? Uh-huh. Okay. All right, let's talk about the total. What goes in the total? 40 out of 40. Hey, guys, what's 40 out of 40? 1 or 100%. Perfect. That is a relative frequency table. All right, now we're going to apply what we have learned. So we have our first lesson application. What are my classmates like? On the first day of statistics course, the instructor gave all 40 students in the class a survey. The table shows data from the first 10 students on the class roster. Identify the individuals and variables in this data set and classify each variable as categorical or quantitative. All right, so our individuals, it tells us that this table shows data from the first 10 students. So the individuals are going to be the 10 students. That's who this data is about. The variables are basically everything that is shown up top here. Those are our variables. So sex, class, GPA, pulse rate, dominant hand, children and family, homework last night, sleep, and smartphone. And now we're going to categorize these as either categorical or quantitative. First of all, sex or gender, that is definitely categorical. We're putting things into categories, people into categories. Class, we have juniors, sophomores, seniors. This is a category. GPA, we have quantitative. That is something that we can quantify is your GPA. Your pulse rate, that is also quantity. That is a quantifiable variable, and so that is quantitative. Dominant hand, whether you're left or right-handed, that is categorical. The number of children in your family, that is quantitative. Now, that is because, remember, quantitative is when we are counting or finding a percentage. So we're counting or measuring something, and we're counting the number of children in the family. Homework last night in minutes. Now, if you look at this, it looks like this must have been some kind of range that was put onto the form. So this is, we're putting people into a category based on a range of minutes. So yes, minutes is normally quantities by themselves, but in this case, because we are putting them into sections, then we have categories. Sleep, the number of hours of sleep, that is going to be quantitative. And then if you have a smartphone, that is going to be categorical. All right, so that's number 1. Number 2, it asks us to, here are the ages of the 40 students in the class, and we need to summarize with a frequency table and then a relative frequency table. All right, so it looks like our smallest number here is 14. And so for my frequency table, I'm going to have 14, 15, 16, 17, then 18. And then if I can squeeze it in here, I'm going to have a total at the end. And I just basically need to count up how many of each of these do I have. So for 14, I have 1, 2, 3, 4, 5. For 15, 1, 2, 3, 4. For 16, 2, 3, 4, 5, 6, 7. So we have 9 for 16-year-olds. For 17, we have 17-year-olds, and then 5 18-year-olds, and that is a total of 40 students. So that's my frequency table. To turn this into a relative frequency table, I just need to turn these into percentages, okay? So I'm going to just kind of do this relative over here. So for the first one, I've got 5 out of 40, which is 12.5%. Then I've got 4 out of 40, which is 10%. And then 9 out of 40, which is 22.5%. 17 out of 40, which is 42.5%. And then 5 out of 40, which is 12.5%. And that is a total of 100%. And that's how we do our first application.